For the following assignment, you'll need to write a proper formula for each of the substances as well as the state of matter, so the phase in which the substance is in. We're going to look at E, F, and G. Start with E. So we have zinc nitrate, which we will need to write a proper salt formula for. We know that zinc has a 2+ charge, and nitrate has a -1 charge. So to combine these together to make this salt neutral, we will need 2 nitrates for every 1 zinc. That's because there's a 2+ charge, and in order to make that 0, we need 2 negative charges to balance it out. So there we go. So we've got 1 zinc, which we always start with in our formula, Zn, and we have 2 nitrates. And the only proper way to write that is with parentheses, NO3, 2, because that's saying we have 2 of this entire molecule. This entire thing, we have 2 of it. You don't want to distribute out the 2 or do anything like that. You need to write it in parentheses. So I'm going to write that big over here. The problem is telling us it's dissolved in water, meaning it is soluble. It will dissolve in water. And there are 4 different types of notation, phase notation. There's solid, which zinc nitrate on its own would be solid, but it's telling us it's dissolved in water, so it is no longer solid. There's liquid, which you may think it is because it is in a liquid state. However, they are not dissolved in anything else. So this is not a liquid. A liquid would be if we could potentially melt the zinc nitrate and put it into a liquid form. It's not a gas, we know that. And the last one is aqueous. Aqueous means dissolved in water. So that is the phase notation we're going to use for this because it's telling us our zinc is dissolved in water. So we put that down next to it, like so. The next one we're going to do is nitrogen gas. Recall from the periodic table that there are 7 elements that exist as pure diatomic elements. Di means 2, atomic means atoms. This means that there are 2 atoms bound together. Here we can see the formation of diatomic molecules. We start off with 2 separate atoms, these are hydrogen atoms, that each have an electron. They both bring an electron to the party. And their electrons are attracted to each other's protons, the nucleus, and they come together to form a diatomic molecule. The sharing of electrons between these 2 molecules is what forms the bond that holds the diatomic elements together. There are lots of diatomic molecules that could potentially exist, but there are only 7 pure diatomic elements. The difference is that they're elements. You could have many diatomic molecules that have 2 atoms bound together, but these are pure diatomic elements, and we can find these on our periodic table. On the periodic table, they exist as the kind of shaded in ones. So we've got 7, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. These all exist in 2. So for nitrogen gas, we're going to have 2 nitrogens bound together because it's diatomic, that means there's 2 of them. So it's N2, and it's telling us it's a gas, so phase notation of gas. As you saw in the simulation, 2 hydrogen atoms were bonding together and sharing those electrons. Diatomics form because it's the most stable form of our pure elements. Just because something is a nonmetal doesn't mean that it's always going to be a diatomic, which is the case with helium gas. Helium gas will not form a diatomic molecule. Therefore, when we're writing it, we just put the element. It's not one of the diatomics. None of the noble gases are, which is that last column of elements. Helium, neon, argon, etc., etc. Those are not going to form diatomic elements, even though they are gases. they will be on their own. So helium is a gas. And there you have it.